Alright, heading into town for another day of service calls today. Got 3 of them on tap. I don't feel so well, so I want them to be expedited. I would not mind if they were all very simple things and I made very little money today. So I want to go ahead and get these things done and get out of here. So we'll try to get a little video of them along the way and see if we can find something interesting. Okay, our first one is we have an old York here, package unit, and nothing's happening. No blower, no outdoor, thermostat control, could be low voltage transformer. We're gonna take a look. Okay, we checked the control transformer. It doesn't have power going to it. Took the faceplate off the focus probe before that and checked red to common, and there was no voltage there, so I knew there was no control voltage. And what I do now is to check these fuses. I'll do ohms or I do continuity on either side of them. See if it'll tone out. That one's fine. It's hard to do in one hand. I'll tell you, I've already done this one. It's high voltage on one side of it, but no tone. That fuse is blown. See if it blows another one. Alright, I carry around several items that come in handy in these particular situations. See if this fuse got a surprise for me here in a second. And, before I go busting up another fuse, I'll go ahead and test it to ground and find the ground wire just to be safe. I can't see it. Testing to the ground wire from that same terminal where we had a problem. Kilo ohms. Not as good as I think it should be right there. I want mega ohms. Alright, I'm going to go ahead and take off these terminals and just go ahead before I go wasting fuses and check and see if we have ground on this compressor or the sump heater. Alright, I got it set to ohms. What I'm going to do is I'm going to set one end, I'm going to clean off part of the copper here and set one end here and one end on the terminal block, and then we'll take a look at it. So if I've already checked it, so I can't do it with one hand, but basically I place one down here on each terminal, scratch off a spot. Actually it came out to be infinity, so the motor windings in the compressor should be fine. We'll probably check the sump heater next. Alright, we're going to check the different legs to ground. See how many mega ohms, if any, we have. We can go to each one of the spots where the fuses were at, across the top, since it's not connected to the line side of the system. Kilo ohms. It's got about a third of a mega ohm. Second leg is open line overloaded. Third leg, not too impressive, 1.69 kilo ohms. To give me one of those mega ohm meters. Definitely better than this. And 8 mega ohms. So something on that last line, we can disconnect it and try it again. See what happens. We can go look at the heater compartment. Alright, I traced our wires down and I found a commonality where they both head. Once it heads over here to the board, it then heads off to the heater. And the other wire headed to the heater. Both of them had kilo ohms instead of mega ohm reading led to the heater. And once I disconnected the wires, they read much higher, leading me to believe that the heater is at least partially grounded in some way. Or, I don't know how the heater can be partially grounded, but we're going to start it up without the heater in place. And hopefully we don't go popping some fuses. Okay, I detached the heater wires because it was grounded and the unit stayed on, the compressor came on, outdoor fan came on, everything was good except the blower didn't come on. So I'm checking to see if there's any damage to this board, because those heater wires are connected through plug to this board, so it could have damaged the board or one of those relays. I got my alligator clips hooked up to the wires that power the blower. And I have them hooked up here, so when we turn it on, the fan is in on position. It should read 240 volts. And it does. But the fan motor is relatively new, so it's a little bit of a quandary. Alright, I'm going more toward downtown Wilmington, which is in between downtown and midtown. There's a lot of rough looking areas like this. And for some reason there's a lot of supply houses in those rough looking areas. I guess they're lease money they're trying to save. So I'm heading over to get a new blower motor because the blower motor was crap. And see if they got the heater. I don't know if they're going to have that or not. But I want to check that out. I need a few supplies anyway, some electrical tape and stuff. And I'm going back to the job to install them. Okay, we got our new blower motor because I don't know exactly if the heater could be capable of destroying the blower motor in this manner. I'm not sure. I went ahead and replaced the blower motor. We got a brand new heater down there. A mess of crap right there. New capacitor. So we're all squared away. No shorting out, none of that stuff. So we should be good to go on this one. Sort of an electrical extravaganza. But electrical heater grounded, causing the fuses to blow. Whether or not that affected the indoor blower motor, I don't know. Could have been just a crap motor. You can see the burnt windings. There's our old heater. Let's see. I know I saw them. Yeah, you can look inside there. There's burnt windings. I don't know if you can see them or not, but they're toasty. So it was shot. Not exactly sure why. Okay, this is call number 2. What we have is a Trane TWP 018, manufactured about a little over 10 years ago. And just doing a little checkup on it. The first things I see is the start capacitor. It's definitely going to be replaced. You can see where it has been leaking. There's some damage here at the base of it. Whenever I see that on a start capacitor, we go ahead and switch it out. Go ahead and do a 521 and replace it. Contactor doesn't look damaged or anything like that. It looks pretty good. Of course, capacitors look like hell. They'll do after a while, but it's probably fine. We'll go ahead and check it anyway, and then start her up and check our charge. Alright, we're gonna put our 521 on just like we've done a few times already here on YouTube. We have 3 leads. It's going to go to the hermetic side of the dual run. It's a striped. You can see that right there. Going to the hermetic side. And we have a common, red. It's going to go to the common side of the dual run. And then we have our black. It's going to go to the common side of the contactor. So we're going to plug those 3 in and I'll show you where that's at again. Alright, we got our stuff all plugged in. We have our yellow, red, and orange stripe wire going to the Herm terminal. We have our red wire going to the common right here. And then we have our black wire going to the common side of the contactor. And it really doesn't matter what side you put it on because it's pass-through on that side. So it doesn't matter which side of the contactor it goes on. We're going to strap these wires in place because it's always to have it a little bit neater because you're going to be the one coming to work on it next, and might as well have it so you can tell where everything's going and everything's not jumbled up. Alright, she's been running for a few minutes, but as of right now, she looked pretty good. Superheat's 11, subcooling's 8. There's no stated subcooling on here, it just has a orifice size, but they went with the air handler that had a TXV at the time. So I'm pretty happy with this. If it stays in this ballpark, we won't be doing anything as far as charge. Alright, been going about 10 or 15 minutes. Our superheat's 12, subcooling's 8.5. Superheat's gone anywhere from not 10 to around 12, 13 here. And our subcooling's gone anywhere from 8 to around 9.5, 10. So we're looking pretty good. All the amperages were good on the motors. Just wanted to check it. Last year I had to put some refrigerant in it. It looks like that might have been just a deficiency that it had for its entire life. So, ironically, it might have run the best in the last 2 years it's ever run. So, we're going to unhook and we'll be on to the next one.